Hi guys, Chris here. How you doing? All right, we're back again. All right, we have a question here. Those of you that ask where we use math and physics and even science in real life, that is why it is called STEM, okay? So all this you see them just the way maybe you only learn the theory. All right, so we have a question here. Don't mind my diagrams, okay? You must have seen the real question in the thumbnail, okay? All right, so we have a question. There's a tree that's about to fall down, maybe, we don't know. And there's a support here, and this support is perpendicular to the tree. Perpendicular means 90. So this way the given information. The mass of the tree is 270 kg, and the tree is in equilibrium. It means the tree is not moving. All the forces are balanced. All right, so this is the trunk of the tree, or close to the root, and there's point P. The support is at point P, and the distance from the center of gravity to the trunk is 1.2. And from P to this. So we're told to find angle theta. So what do we do? Now, if you have watched my previous videos, if you don't understand resolving forces, you're going to find this very challenging. For inclined plane, please watch my video on inclined plane. I gave all the scenarios. For inclined plane, if this is theta, and I have a particle here, this is the weight of the particle. I proved, check my video, like I said, this perpendicular line, this is always theta. So in this question, I'm going to use moment. Moment is force times perpendicular distance. So this is the weight because it's the center of gravity. So the weight is here, mg. So force, if you bring this down, it's the same thing. So I'll just make it down so that you see. It comes down, so this is mg. So mass, force times perpendicular distance. Force is weight. So mg, so I'm just going to write my equation. So mg, so for here, so I'm taking moments to q because this is the support. So this will be mg times 1.2. Force times perpendicular. You can take here as 90. Force times perpendicular distance because it's already perpendicular to the distance. All right. How do I deal with this force? That is the question. So for this, like I just said, I could make a line here, and this will be theta. Don't mind the rough diagram. So I'm using this. So because theta, so let me just do it here. Cos theta is adjacent, so theta, so this is 1.6 over hypotenuse. Now hypotenuse, that's QP. You might ask, why am I finding this? Now you should understand the question, okay? I need, the force is already perpendicular to the tree. So I need the force and this. I need the force and this. So that is why I'm trying to find QP, so that I can multiply this and the distance. So I'm just resolving the distance here. So I'm finding the perpendicular distance to this force. So here, it's not my concern. So I'm finding the perpendicular distance to this force. So you should understand what's happening because it is force times perpendicular distance because this is 90. So force, distance. So I want to resolve this distance to find this perpendicular guy. So that's the force 1800 times the perpendicular distance. So QP here, just cross multiply. So that will be 1.6 over cos theta. So 1.6 over cos theta. From here, you should know what to do from here. So I will just move this to this side, bring this down. So cos theta, don't waste time in exam, mental math. So 1800 times 1.6 over, bring this down. So mass is 270 times 9.81 times 1.2. So let's see, 1800 times 1.6 divide 270 times 9.81 times 1.2. So that will give me 0.9061. So theta, cos inverse of that, will give me 25.0. So my angle for this to be in equilibrium is 25. It's a tricky question. So where some of you will run into problems is trying to find this. We need the force and the perpendicular. So we need to resolve this perpendicularly. So this is the concept. All right, guys, if you have any question, just drop it in the comment section and take care of yourself.